Pwede ka mag-small talk, huwag ka lang usama ng lecture mo.
Hindi, about incentives. It's optimal.
O yun, huwag mo na isama yun. Huwag mong ganun. Huwag yung
guys, doon nagsabi.
No need to get mine up.
Hindi pa ako nagtagdang. Well, wala pang yung
ano yan?
feedings plan.
One day.
Iba crush point.
1-5.
Huwag mo sa kanila. Alam ko lang.
Chatting nga,
Legit. Alam ko na yung present ko mag-2. 1-5 ibigay sa akin lang.
ayaw mo ko rin.
Sabi, wala mag-grade ko sa 1-5. Hindi sure magbibigay ko sa akin. Sa mga lek-lek. Magano.
Kami sir. Sir,
Tutok alin yun.
ano siya?
Yun lang.
Mama siguro.
Habang
I'm just a speaker. Other than that.
But ito si GP. So I hope everyone had a good lunch. Good afternoon and welcome to our talk on state observation and data analysis for resilient electric distribution systems. I hope everyone's had lunch right now and you might be feeling sleepy, but we'll have a lot of exciting talks to talk about today. So to start off this plenary, I'd like to introduce Dr. Michael Angelo Pedraza, who will be leading this introduction to this. So, yeah, I'm calling Sir Mike.
Weird yung audio.
Is there another mic here?
Yeah. Medyo mahina. Guys, may presentation ako. Nakaload na ata. Yeah. Nakaload na. Yeah. Naka-extend lang yan.
F5.
Everyone, mag-tapos sa lahat. Ay, matapagda. Kailan niyo ba ako?
Dapat.
Hindi na ako naturo ng 33 eh. So, well, some of you, ano Ay, joke lang. Okay. Start, survey. Ayan. Dami. So, most of you are 190. Parang wala yung mga 180. Mag-190. Fourth year. Naka-stream.
Naka-steam.
Stream yan? Okay lang, sir. Okay. Grad students. Grad students. Yung mga tao ba kayo? Yeah, so okay. So, I was tasked to give an introduction about grids. Actually, for 20 minutes, 80 minutes, I'll talk about project. I'll start with Picari, no? Because you've been healing of Picari. So, ano ba talaga yung Picari niya? Okay, and then I'll talk about the project, and then I'll talk about some of the activities that we have done, hopefully to encourage the undergrads to pursue further studies after you graduate. I'll probably have 2 or 3 or more undergraduate. I hope that this will help you decide to pursue graduate studies beyond after graduation. And then I introduce to you some of the talks that will happen this afternoon. Anyway, aside from me and Dr. Jordan, the rest for this afternoon are students. So they are masters. So they are master students who are working with us in this project. Okay. So first, Picari is the California Advanced Research Institute. It is a project that was funded by the Philippine implemented Mission of Higher Education. So, around 2012, and the vision then of Dago Banatao, narinig ko na ba kung si Dago Banatao? Ay, hindi ko siya kilala. Okay. Sige, kung ikwento ko kung sino tayong humabaan. So, assignment, please, Google kung sino si Dr. Dago Banatao. Okay? So, this vision back then was to help Philippine universities to leapfrog, essentially to increase their research capacity, and to do that, he will facilitate the partnership between Philippine universities and universities in US, in particular, University of California system. Okay, so he lobbied the government to provide funding for research, for collaborative research. After 3 years, pinanak yung Picari. Okay, so we have California Advanced Research Institutes, and some research projects. This project, meron siyang scholarships and training components. So we are also looking for scholarships. It's offering these scholarships. Okay? And the two priority areas, one is the infrastructure development to which we belong. So that's the local and human components, blah, 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 blah. Processing of the management of electronic information. Okay? So if you read that, mostly 3 siya, electrical engineering. Okay? That was the but if you go to the website, you will see there are a lot of projects under the IT. There are Picari projects implemented in the other departments like M, ChemM, and ComSci. Okay? Our project is not only in the 3.0. In fact, there are several Picari projects under 3.0. So, from Power Group, we are one of them. Michael Group, they have a Picari project. The Wasem Group, they also have a Picari project. And also sa CM, they also have a Picari project. Okay, so there are at least four Picari projects in the building. Okay? So And then the other one, the health innovation functional medicine. Hindi ko na siya explain, but one manifestation of this is, kung you happen to say walk dito sa likod ng science complex, meron dyan isang bagong building, yung gym center. So it's one of the outputs of the HITM component of project. Okay? So, for our project, it's called Resilient Grid. So,
here that a lot of the decisions, all decisions should be based on what information is made available to the decision maker. Okay? And the more information we have, then we believe that the decision maker is better equipped for that decision. I'm enjoying this food. Okay lang ba sa inyo? Nakakalaki.
Okay. Ginagawa ka rin.
Ginagawa ko nito. In addition, so basically the first set of slides I have talked about the sets of information that would be available in the network. But another dimension to be recognized as well are time scales involved here. So when we see plots like this, we normally look at the labels for the axis. So yung pinakamalitiindihin ko dyan ito, millisecond, second, minute, hour, and decade. What we're saying here is that we normally make this as far as planning is concerned in terms of number of months, even number of years. And I think you can imagine that. So at these time scales, these are the decisions that we are making. However, on the other extreme end there, we say that as far as switching devices are concerned, the power electronic device we normally operate this in the microsecond range. Okay? Our protective relay here operates in millisecond range. So we say that because of this range of this dimension here, there are information that should be made available in a timely manner. So if you are doing this T&D planning here, it doesn't matter if the information comes to me every hour or every day, once every day or once every month even. But if these are the sorts of decisions that I'm about to make, then I would have to make sure that the information should be provided to me in a timely manner. So these pink arrows here, basically, this highlights the important time scales here. Usually one AC cycle, basically yung one cycle po ng 6 minutes natin. And then this could be a second, so every second you can make decisions as far as automatic governor control is concerned. So but the point here is, after you've seen the information that I required earlier, you also recognize how soon can we make this information available to us. Okay? So those are the two things: what are the information and when will I get it if I'm about to make a decision. Of course, I always refer to myself as a decision maker or operator, but in an ideal world, you actually can make, I can make myself irrelevant here. You don't need me, you can have a machine make all these decisions in behalf of us. Okay? So all the more that we need information that comes in rather frequently. Of course, the word frequently is quite relative right now. It could be very frequent at this stage. Previously, a daily information is very frequent. Okay? But in your day and age right now, we really have to make it available at the right time. And so, I bring you this nice piece of equipment here. So we call this the PMU, the micro PMU. And Lian has helped me with this afternoon. Ito po yung sample nito. Sige, pag-check natin. Ang gusto ko lang, of course, you can see a picture from the slide there. But what I want to highlight this is, it's a very small device. In fact, yung form factor po ito, yung size ito is exactly the same as your miniature breakers. Yung MCB po natin. So ganyan lang po kalait yan. Actually, what made it a little bit bigger is the one Leanne was holding there. That's the GPS receiver. So this thing here actually provides this information to us. So it measures both magnitude and voltage and current. Leanne here has an example of the current transformer for us to measure the current. Of course, yung voltage measurement po, mas madali naman magsuot ng voltahe, kakabit na po sa terminal po. So basically, a PMU will measure for us voltage and current, depending on the leads and the sensors that we have, and the instrument transformer that we have. But more importantly, that's the reason why it's called a phasor is because it measures voltage magnitude and angle. Okay? Of course, a typical meter that we have, voltage meter that we have, will only measure the magnitude, but none of the angle. It can measure for us the RMS value of the voltage. It can, if you have an oscilloscope, you can see the time vein signal, basically how it varies in time. But typically, we don't know the phasor for this. voltage signal, or even current signal. But this guy here is one that starts to measure both the magnitude and angle for these voltages and current. Is that important? I suppose this equation looks familiar to everyone. Pag yung tatlong estudyante, okay na yun. This one looks familiar. So basically, this simply tells us that the power flow can actually be approximated by this constant, this constant, and is a lot affected by the angle. We call it the power angle, the torque angle means the same thing. Okay? But what we're saying here is, the moment we get to measure the angle, 30 minutes left. The moment we get to measure the angle, then there are a lot more information that could be made available to us, which was not available to us previously. Let me go back to this slide here. On top of that, this information are synchronized, timestamp. Right? So guys, the GPS, it's timestamp. If I measure one from here, from this side here, another guy measures from another side of the on-campus here, that is part of Luzon grid, these are all timestamp. And we can actually make decisions based on information from a wide area system. Of course, the accuracy is also cool. This is important because for a distribution network device, higher resolution, higher accuracy is really important as compared with that on the transmission side. Of course, having said this, how important this device is, PMUs have been available in the transmission network for many decades now. Okay? But the emergence of this equipment to be used for the distribution network, and even at the consumption level, 220 volts po yan, sinasaksak lang namin minsan yan sa saksakan doon. Okay? So that's the beauty of this device here. We can now do this monitoring at the low voltage level. Of course, there are a lot more challenges as well. So I don't have much time right now, so I'll go quickly with this. So this simply differentiates the transmission level simplification. But if you remember, this does not apply to distribution level because this assumes that the resistance in the system or in the wires are negligible. If you don't neglect the resistance, then we go to this simplification here as approximation. But again, these voltages here, angles here, the difference that is, should allow us to predict the power flow, both the real and reactive power flows. Just some pictures of what we have measured so far in the laboratories here. So we have our own local SCADA, and then the measurements are there in red. And then we use our PMU as well just to measure a specific, for a specific period, and that's what we have, that blue thing here. Notice that this looks like straight lines here, but they're not. These are all discrete measurements as well, the blue ones. But because of the higher resolution, they now look like as continuous plots. Okay? But these are discrete. How fast is this? Basically, you can set it for one measurement per cycle. Okay? So these SCADA measurements there are normally at a sampling rate of one measurement per second. So you can actually have about 60 to 120 times faster for your PM. So that's how good these measurements are. Pagpatawag ko, hindi nakakalibrate, sisilian na. So, hindi nakakalibrate ang layo nung nasusukat ng PMU ng SCADA po natin. However, it looks, well, it is very uncalibrated. Pero po, mababa na po naka-zoom in tayo dyan. No? So if you put this range here, wala pong 8 volts lang po yung range na yan. So itong variation at sa 5 volts lang po yung range na yan. Okay? Pero anyway, so kung hindi sila nag-match dalawa. But what we want to highlight is basically the difference in the resolution. Looking at this further, this actually is what we obtain when we measure the output of our solar PV inverter terminal. So this one is the voltage and this one is the current flows there. Okay? Again, yung range po nito is for a one full day. So you can see that this must be the daytime when the solar PV are producing power. So these are the output currents po. And notice the high resolution there. Kita-kita mo, syempre, sad po ang jagged po, hindi maganda tingnan. But that's exactly what it is. So yung solar PV po natin, even if the sun is up there shining, the output power from the PV terminal PV inverters are not really throughout the day. And you can see basically what explains the variations. This could be cloud covers, shadows basically, that may affect the output of that PV inverters. The time's up about. Sorry, we have to finish rather soon. On top of that, so we have the nice equipment over there. that allows to measure at high resolution and high frequency. But there should be an infrastructure that should support that as well. So related to that is what we call the Berkeley 3 database, again developed as well with ESL and UC Berkeley. And this is a database basically. It's a database that is a little bit more superior than the typical database that we have because it has to be able to accommodate all these loads of information that may come in. Okay? So this is provided to me by Kyle. Kyle is the guy if you need to ask anything, if you're a database guy here and you're curious about how to manage a database system like this, and then we can point you to the right persons. But again, Kyle is consulting with the people back at California as well. But basically what we're saying here is with the huge amount of information that comes in rather quickly, rather fast, so the database should be able to accommodate that. Okay? And of course, we can also imagine that there could be some errors in the transmission of the information. And because these are all time-stamped, so you can actually realign this data, even if they don't come synchronously or didn't come on time. Okay? So if they come asynchronously, then you can still file them together in the right order. So as a summary, in that 15-minute presentation, so we say that there are sensors that are available in the modern power systems right now, and we cannot underemphasize basically or underestimate the value of the information and the communication and the information that's made available to the communication system that is in play right now in the power system. And the challenge right now in our generation is to make the most out of this information and make sense out of this information. The title of this afternoon seminar is about observing the power system. So hopefully with sensors like this, we are in a better position to make observation. But in the next few presentations, kaya po ako yung na kasi mas excited yung mga kasunod. Introduction lang po kami ni Sir Mike sa mga sunod presentation. We now want to make sense and use about this of this information and data that's made available to us. Okay? And hopefully we can make smarter decisions in the process to operate and to manage our distribution networks. With that, I finish my presentation. So those are our email addresses. You can contact us if needed. 1 minute lang daw. So 1 or 2 questions po, you can come back.
Kasi hindi natin pwedeng ayos yung
ayaw na magtanong kasi naman yung nasusunod si person.
Ayaw kasi
Anyway, thank you very much for your participation this afternoon. If you have anything here that piqued your interest, please come and approach us right after this presentation or on the days that you have. That will be most welcome. Thank you. Sige sir, sige na.
Baka pwedeng gusto nyo gamitin. Sige, dito na kayo.
Thank you, Sir Mike, thank you, Sir Jordan, for that wonderful presentation. So, I would like to introduce the next speaker who will actually try to make sense and of these microviews. And I'd like to introduce Paul Bundok, who's going to have his presentation on micro PMU placement and state estimation using that will use it for the electricity grids.
Hi, good afternoon everyone. So I'm Paul Bundok. Currently I'm working on PME placement, technically PME placement and state estimation. So I will expand on it later. Pero I chose PME placement and state estimation kasi hindi naman ako EE guy nung undergrad. EE person ako, ECE person ako nung undergrad. So I had to come up with something na naiintindihan ko. So, PME placement state estimation, yan, medyo naiintindihan ko yan kasi pwede ko gawin everything in math as opposed to yung typical EE measurements, typical EE knowledge. Okay, so, ayan. State estimation is the process of estimating the system states through available measurements. In layman's terms, pwede natin siyang i-compare, let's say, sa interpolation, wherein I know X, I should be able to determine the value of Y. So, but in the power system lens, yung system states can be powers, energy consumption, voltages, magnitudes and angles, current magnitude and angles as well. Tapos, with those information available, that ma-estimate or gagawin tayo ng insight sa other information na meron dun sa buong network natin. So typically before, meron tayong SCADA systems wherein yung measurement nila is asynchronous. Asynchronous in the sense na pwedeng dumating information, pwedeng hindi, or pwedeng dumating 1 second later, 2 seconds later. So hindi nagmamatch in a temporal sense yung data na dumating. And speaking of temporal resolution, usually yung temporal resolution nila is typically 1 second. Kaya share ko na rin. May friends ako na nakapag OJT I think sa Beneco. Tapos part ng sa mga ginawa nila is doon sa SCADA room, nandun lahat ng measurements. Tapos before nagkaroon ng servers and all, lahat ng measurements na yun, ililista mo sa logbook. So, ililista mo 15 minutes dapat. Within 15 minutes matapos ka na. Tapos after another 15 minutes, darating na naman yung bagong data. Pero imagine it na yung data mo is every 15 minutes lang dumarating. So, medyo laki ng interval na yun. So, and ngayon, nagkaroon ng PNG technology. So, part na ngayon ng state estimation is yung data fusion wherein we have available information such as yung SCADA readings, load forecasts. Pwede natin sila merge with PMU data para makapag-state estimation tayo. Or, we can do it purely with PMU information. With PMU placement as well. Pwede natin siya gawing topological based. Meaning, ang alam lang natin is, ito yung single line diagram network ko. Saan ako optimal maglagay ng PMU? Or pwede yung data-driven. Ito yung data na nare-read ko. Saan mas okay maglagay ng PMU para ma-optimize yung readings para gamitin for state estimation. Let's say, limbawa, ayaw ko maglagay ng PMU somewhere na yung information, may information ako dun pero hindi ko naman nagagamit. So parang useless yung paglalagay ko ng PMU doon, might as well saan sa ibang location na. Tapos, you guys might be thinking na magkaibang idea yung PMU placement sa state estimation. Pero, apparently, hindi mo sila pwede i-decouple. Kasi, your state estimation is only as good as your PMU placement. Tapos, yung state estimation mo, ang readings mo magagaling, yun nga, sabi ko, it's only as good as yung PMU placement mo. Tapos, minsan yung PMU placement mo, magsasabi rin kung aling state estimation procedure yung okay gamitin or okay ba yung this procedure over the other. Okay, so start muna tayo sa PMU placements. I'm taking from paper of Aziz Mabani. Siya talagang PMU placement guy namin. Tapos, his considerations is, sa systems natin, meron tayong zero injection process. Or, ito yung mga process na walang load or walang generator na nakakabit. So, para lang silang, isipin niyo sa breadboard, para lang silang nakalutang na butas doon. Pwede kang kumabit ng wire doon. Pero walang nakakabit na resistor, capacitor, or anything. Tapos, second sa considerations niya is, nagkaroon ng line outage. Nabuti yung line mo dito, hindi na available yung information. Anong gagawin natin? Tapos, PMU channel limitation. Usually kasi, ang assumption is, meron yung PMU natin, ang assumption ng papers, kaya niya mag-hold ng unlimited amount of information. Where in fact, yung PMU na pinakita kanina ni Sir Jordan, meron lang siyang 12 information channels. So, kailangan ma-utilize mo yun lahat or masulit mo hindi ka pwedeng lumampas dun minsan kasi wala eh, hardware limitation na siya eh. So ito yung proposal na placement. I think ito ay sa 40 bus or 118 bus network. So, nag-implement siya ng integer programming. Yung traditional way of implementing it. Ito yung lumabas na PMU placements. Tapos ito yung indices na ginamit niya. Tapos baka nagtatayo, bakit nagmamatch lang dun sa yung method niya dun sa traditional ILP. Where ang ginawa niya dito sa optimization method niya is in-optimize na niya yung buong system in such a way na kinonsider na niya itong zero injection buses, line outages, channel limitation. So mukhang sa results na mukhang pagas lang sila, pero mas mabilis na sobra-sobra yung ano. Tapos kaya rin siyang i-measure, kaya siyang gawin sa typical machine. Whereas yung ILP, tinry ko siya dati, naubusan ako ng ano. Nagmumukhang baby yung PC ko, hindi umiiyak siya. Ito, I'm taking from the paper of Ren Santos. I think gumagawin na siya. Okay. So, data fusion. Yung method is, gumamit siya ng PMU data, tapos, syempre yung mga utility natin, meron na silang scale. So, sayang yung investment. Pwede natin i-put into good use yung information galing sa scale. Tsaka, ano siya eh, the more information, the better. So, ito yung method ginamit niya. Alam niyo yung Y-bus measurements, yung PMU measurements mo na nag-refresh, I think, ang ginamit ata is per second or per second yung refresh rate ng PMU niya. Pwede yung measurements niya, I think, per second din or every 15 minutes. Tapos in-use niya yun gamit I think Kalman's filter. Tapos we can see here na every time na nagdadagdag siya ng PMU sa system, sobrang nagiging mas maganda yung result na nakuha niya. Whereas yung, eto na yung percent error. Nakikita natin yung meron sa typical estimation, meron siyang 6.12% error. Tapos na-bring down niya yung 6.12% error into around 2.5% na lang. Also, yung number of iterations, pwede siyang pumas in this case, pero in this case, halimbawa, nagpababa niya yung average number of iterations. Okay. So, yung current work ko, ako yung gumagawa ng PMU information lang yung gagawin. Kasi anong rational behind it? 1 second or 15 seconds nag-refresh 1 second to 15 minutes nag-refresh yung skata mo. So, minsan hindi na nag-aalam yung information or ibang papers ang suggest pa nila is i-deduate mo or the weighting wala nang value halos minsan yung information. So, kung ganun yung speed ng PMU, tapos ito lang yung speed ng SCADA system natin, bakit hindi na lang tayo ng PMU system only? Tapos, ito yung results ko. So, tinry ko siya sa 34 bus network. Tapos nakikita natin na kailangan ko lang ng 5 PMU apparent, 5 PMU apparent, 5 or 4, tapos maganda na yung estimates ko. So, etong yung results. So, yung red yung dalawang PMU, obviously, di ganun kaganda yung information behind it kasi ano yung spread. Tapos, makikita natin habang padami yung PMU, palit yung error spread. Yung yellow space dito, 5 PMUs yan. Pero, hindi, meron lang siyang optimal count kasi makikita rin natin dito. Pagdating ng 5 onwards, halos wala nang improvement dun sa dami ng PMU tsaka dun sa error na sa estimates natin. Okay, so future work, state estimation, other machine learning techniques na pwedeng gamitin. Kasi yung sa akin, ang ginamit ko is linear regression lang. So, madami pang sophisticated na machine learning techniques. Bad data scenario, ito yung mga instances na hindi dumating yung data ng PMU at all. Or nasira yung PMU for some reason. Or pwedeng may pwedeng i-consider sa bad data yung halimbawa yung mga city mo at saka PQ. Sources of error din yan minsan kasi accurate lang sila to some degree tapos nilagay mo sila sa PMU. So yung error doon matatransfer na ngayon sa measurements ng PMU. PMU outage scenario. Ito yung scenario na wala lang yung PMU down. Nagkana pa ba yung state estimation procedure ko? Or ano yung backup sakali na state estimation procedure? Pwede nyo naman sa PMU placement. Meron yung tinatawag na constraint placement wherein eto nag-identify na ako. Gusto ko maglagay ng PMU dito. Saan pa ako pwede maglagay? Na dapat yung state estimation ko okay pa rin, or pwede rin PMU placement doon sa constraint placement. Gusto kong maglagay sa isang location kasi maganda doon maglagay. Kaso, bawal ka daw doon maglagay for some reason. So, dapat i-consider rin yung constraint placement, PMU placement. So, in summary, mahirap siya. Hindi naman siya mahirap siya, pero yun nga, yung state estimation and PMU placement, kailangan nila mag-work together. Minsan may matching placement for certain PMU, may matching PMU placement given state estimation procedure and vice versa. So, questions, bro? Questions.
Ano yung mic?
Walang mic eh. Paabot na lang.
We can't, naka-ano eh. Are there any questions?
Any questions over ba? Any questions?
Yung mic. Hindi
May mic ba tayo?
Hindi ko bagaan.
Baterya palitan. Palitan. Discharge na lahat.
Kung gawing once, twice, yung bago.
Okay, if there are no other questions, we can thank you, Paul, for this insightful talk on. Oh, there's one question over there. Okay. So how can we bring it there?
Okay.
Repeat the question.
So how do I connect yung PMU placement and state estimation with resilience? So syempre, kailangan yun nga.
Pag-repeat lang natin yung question.
Natin yung state estimation para magkaroon tayo ng knowledge within the system. So at least as pinaka-basic, at least may alam tayo sa system natin. Tapos, I think yung work namin tatlo, ako si Aziz, saka si Renz, nag-deal kami with yung snapshot lang ng system, normal operational system. So, nakapag-estimate tayo, ito yung lumalabas. Tapos, biglang may nakita tayo na, may abnormal reading ako. Doon na papasok, I think, yung ibang topics which is fault or islanding or yung mga issues with DERs. Pero in terms of resilience, parang ito yung state estimation, I think yung pinaka-basic or pinaka-baseline ng data analytics. Tapos from the state estimation, doon na mag-branch out yung other techniques, other data analysis na rin natin gawin sa system.
Okay, all right, sige. Thank you, Paul, for this insightful talk on state estimation. I'd like to introduce the next speaker who's going to use these state estimates to actually make detections on faults. I'd like to introduce the next speaker, Lady Joel De La Torre, who will discuss her topic on fault detection.
Hello. Hello. Okay, good afternoon. So actually, hindi lang naman fault detection yung sasabihin ko today. So, yan. Actually, hindi nga lang din classification. Pwedeng magta-touch din ng fault sa location. Kasi fault detection, classification, and location are all integral parts of resolution ng fault. Okay. Okay, so yun. And also, I'll not only be presenting my work, so kasama din dito yung work nung kasama namin nag-PhD. So yun. So, ano nga ba? Faults. So, alam naman natin, it's an unintentional connection between faces and ground. Tapos, what we don't really know, or parang neto lang, natin malaman is meron lagang low impedance fault tsaka high impedance fault. So, boom, yun. So, yung low impedance fault, yun yung alam natin, yung common na taas yung current na tawag na generate niya. So, yun yung, parang kapag sinabing fault, yun yung unang-unang pumapasok sa isip natin, di ba? Yung high impedance fault, siya yung parang hindi masyadong obvious. Kasi actually, hindi naman talaga siya obvious pag tinitingnan mo na yung measurement. Kasi mukha lang siyang load na makalat, na magulo. Pero apparently, pag tingnan mo dun sa mismong location, meron na palang fault na nangyayari. So yun. So, syempre importante na ma-detect o na ma-resolve ito kasi it may disrupt normal system operations. And yung high impedance fault, dahil nga mukha lang siyang load na hindi siya technically makaka-disrupt ng equipment mo, hindi siya mapapansin ng system mo. Pero, ayan, yun kasing mga nasa gilid. Yan, arc flash kasi usually high impedance fault. So, yan, medyo delix kasi siya sa... Delix. Okay, I'll be formal. Medyo harmful kasi siya, okay. So, yun. So, it can compromise equipment, personal safety. Goods na ako. So, ano ba yung traditional fault resolution strategy? So again, I've mentioned the importance of detection, classification, and location para ma-resolve yung situation na yun. So detection, meron bang fault na nangyari? Ano ba yung nangyari na to? Is it a fault? So, traditional method is use over current relays. Alam natin to, e-students, alam na natin to. So kaso, applicable siya for low impedance faults. Sabi nga natin, yung high impedance faults, hindi naman siya mag-generate ng malaking current. So, hindi niya naman matitip yung overcurrent relays. So, dyan pumapasok yung specialized detection systems. Kaso hindi naman siya sulit gamitin for impedance faults lang. Mag-install ka ng marami, tapos isang type lang yung gagawin mo. And outdated na rin yung mga methods mo. So, yun. For classification naman, so what type of fault is there? So, pwede, di ba alam naman natin na mayroong mga single line to ground, double line to ground, ganyan. Important din kasi yon para dun sa next process, which is location. So, mas madali natin siya mananalo down. So, ang ginagawa doon, yan, deterministic methods, as in yung kapag may measurements ka. So, ano bang, parang based sa measurements na to, ano kaya yung nangyaring fault? So, medyo matrabaho siya kasi kailangan i-sweep yung lahat ng measurements. And hindi na lahat ng measurements mo accurate. So, yun. And last is location. Siyempre, pag nalaman mo na merong fault, classify mo na siya, hanapin mo kung saan siya para doon na tayo pupunta at i-resolve natin. So, saan ba nangyari yun? Some strategies is impedance-based methods. Merong relay, di ba? Yung distance relay, ginagamit niya yung parang reactance or impedance dun sa ano. So yun, para malaman niya kung ma-estimate niya kung nasan ba nangyari yung fault within its parang area. Pwede rin naman, ito din yung isa, yung outage mapping. So kung sino yung, kaya sa Meralco, pag may tumawag na person na wala po kaming kuryente dito, tapos yun, pupuntahan siya ng mga linemen sa ayusin, yung outage mapping. So parang, saan ba nangyari yung outage na yun? Okay, so yun yung tatlong parang important steps para ma-resolve yung fault. So yan yung traditional, yan yung that. So syempre, meron na rin bago. So dito mapasok yung data analytics. So kanina na-mention ni Sir Jordan na merong bago, yun nga yung micro-PMU. So yung information from the micro-PMU, pwede tayo makakuha ng maraming data doon kasi high resolution siya. And what are we going to do with that data?
Mamaya gusto mo
So yan, may parang 3 steps.
explain lang nung part.
So yun. So we have if we have system-wide facial measurements, we can do some feature engineering. Later, medyo madidiscuss yan. So under that is feature construction and feature selection, and then model induction. So gagawa tayo ng model para ma-solve yung problems kanina, yung detection, classification, saka yung location. So yan. So from measurements, meron tayong facial measurements from different. So yun nga, yung sinabi ni Paul kanina na optimal placement, syempre may malalaman ka na agad yung information. So dun sa mga measurements, dun sa ano na yun, sa mga pinaglagyan mo ng PMU, gagawa tayo ng features. Okay. Feature construction is done to extract underlying patterns and or to change representation of raw data. Tapos ito, handcrafted features that are knowledge-based or taken from intuition. So, sige, ang deep. So, feature construction. So, from meron ka kunwari measurements ng voltage. Pag yan straight line lang, wala na tayong masyadong makikita dun. So, parang ang feature construction, paano natin siya makikita in such a way na parang magiging intuitive sa atin na, ay, may nangyaring something. So, kunwari, may fault. Siyempre, titignan mo, usually, yung current stream. Diba? So, may gagawin ka ba dun? Or igmaminus mo ba yung measurement from one point to another para ma-compare mo kung may nangyari ditong fault or wala. Parang ganun. So, yun yung feature construction. So, ano yung mga characteristics na mag-make sense para ma-solve mo yung problem mo? Yes? Feature selection naman is to find relevant feature subsets. So, nakuha mo na lahat ng characteristics na relevant. So, yan. May information na makukuha sa voltage, may information na makukuha sa current, sa power, etc., etc. Pero kailangan mo ba sila lahat? Kasi, kung hindi mo naman kailangan yung iba, pwede mo naman silang tanggalin. Kung masasabi naman na siya ng ibang features. Kasi, una, sayang din sa oras yun. Parang, pinaprocess mo sila lahat, kaya mo pala sila i-process in a fraction of the time na i-process mo sila lahat. So, yun. And then, and last is yung model induction. So, you start to develop a model for a specific problem. So, meron ka ng measurements, nakuha mo na yung kailangan mo dun sa measurement. So, ano na yung gagawin mo? So, dun pumapasok yung model induction. Ayan. So, dito. So, ito na yung pumapasok na yung work namin. So, basically, what I'm working on is fault detection of a high impedance fault. So, ang problema kasi dito sa high impedance fault, dahil nga hindi natin siya masyadong alam, kasi hindi natin siya masyadong nakikita, wala masyadong data na makukuha from that. So, paano mo siya ma-detect? Di mo nga alam kung ano yung itsura niya. So, the goal is, for now, to develop and simulate a high impedance fault model and demonstrate the characteristics of a high impedance fault. From here, pwede na natin malaman kung may presence ba ng high impedance fault dun sa network mo. Alam mo na kung ano yung itsura niya, kung ano yung itsura niya sa measurements, tapos kung paano siya naiiba dun sa iba. Gets? So yun, dito, ang parang na-solve nitong from here, nandun siya sa parang measurement part. Kasi kumukuha ka pa lang ng data, medyo bitin ka na kaagad kasi nga wala naman tayo masyadong data dun. So yun dun pumapasok tong ginagawa ko. So, develop ako ng model para malaman ko ano yung itsura ng high impedance fault. Tapos, malaman ko kung ano yung features na relevant para sa akin para ma-detect ko na siya sa susunod. Okay? So yun, future work kasi dito, after syempre malaman kung ano yung itsura niya, kung ano yung aabangan ko dapat na characteristics, ide-detect mo na siya in a data stream. So yun, okay? Tapos, so yun yung sa fault detection. Tapos yung next, ito na, yung sa classification and location. Ito work na to nung kasama ko. So, dito, doon na siya sa feature construction, tsaka sa feature construction, feature selection, tsaka sa model induction na part siya. Okay, so yun. Ang ginagawa niya, meron siyang dalawang induction algorithm. So gumamit siya ng KNN or K nearest neighbors, tapos random forest, para dun sa dalawang problem niya. Yung isa, fault zone classification, yung isa, fault location. So yun, isa yan. Tapos yun. Ang kanyang conclusion is, feature engineering improves model performance. So kapag alam mo na kung ano yung gagamitin mong features, parang hindi yung nagbara-bara ka, naglagay ka lang ng measurements. Mas improved yung performance mo. Ayun, kaya dun sa accuracy, sa table 1. Yan, so dito sa table 1, so ito yung model niya. So pag ginamit niya si KNN tsaka CRF, okay? Kapag magnitude lang daw yung ginamit niya, ito lang yung accuracy na nakukuha. So pag tinignan mo, or ito, pag phasor, so dadagdag mo yung angle information, tumataas siya, yung accuracy. Tapos kapag nag-engineer ka na ng features, mas mataas pa yung nakukuha mo. So, bottom line, kung alam mo na yung features na gagamitin mo, or na-tune mo na siya such that ito lang isa-select ko, tapos dito lang ako mag-base na decision ko, tumataas yung accuracy ng fault zone classifier. Meaning, mas madali niyang na-narrow down kung saan nangyari fault. Tapos, ayan, so yan, angle information improve the feature space, resulting into more accurate fault zone location model. So yun yung pag nagdagdag ka na ng angle information. So imbis na magnitude lang, nagdagdag na rin ng phasor. Yung phasor, nagdagdag ka na ng angle information. So ito naman, sa fault location regressor, ganun din may trend na RMSE kasi. So dapat mas mababa yung error kapag nagdadagdag ka ng additional na measurement. So for here, yan, magnitude lang yung ginamit niya, medyo mataas pa yung RMSE. Tapos bumababa na nagdagdag ka ng angle. Tapos bumaba nung nag-engineer ka. Ay, hindi, tumas pala. So ito, yung sa angle, bumaba nung nagdagdag ka ng angle dun sa measurements. Okay. Ayun. So, bottom line, next steps pala dyan is, paano naman kung mali yung data na nakukuha mo, meron kang irregularities dun sa measurements, magiging ganyan pa rin kaya yung mangyayari dun sa results. So, yun. Bilis. Okay, tapos na. Questions? Okay lang.
How was feature engineering done, basically, in the case of fault class detection?
Okay, ulit na yung question.
So, feature engineering, yung sa kanya, ginawa niya, yung from all of those,
How are they extracted, basically, the features?
Most of them.
Sorry. Okay, so tinanong niya parang how are features extracted. So, meron lang siyang 3 measuring points, yung mga PMU. Tapos, lahat yun kumukuha ng magnitude ng angle, ganyan-ganyan. So, yung features niya, yung raw measurements na yun, meron din siya yung difference dun sa between 2 measurement points. So, kunwari, for measurement 1, magnitude nito minus magnitude nito, pati yung angles, tapos yung sa phase A, B, and C. So yun yung mga features na ginamit. Tapos from there, kumuha lang siya ng relevant na schemes. Kasi marami yun eh. Sipin niyo kung lahat ng points, lahat ng differences, lahat ng phases. So yun, kumuha lang siya ng relevant from there, tapos yun yung gamit niya for decision making. Kung saan yung fault zone or location. Questions pa po? Doon po pumapasok yung optimal placement. So, hindi pwedeng lagyan ko ng PMU lahat ng points na yon. Kuwari, syempre maraming boses sa network. So, doon papasok yung kaninang minention niya na dito lang pwede maglagay kasi una, magastos pag marami kong nilagay. So, mas nasasagot nila yon yung kung ano yung criteria ng pagpili ng optimal placement. Kasi us, we assume na ito na yung placement na binigay sa amin. So, what are we going to do to work with the data that we have? So, yun. So, yung answer po sa question, yung ano yung criteria, hindi pa ko yung kailangan sumunod. Basically. Good,
Wala kasi tayo mic. Gumagana yung mic yan sa normal classroom.
Ano kasi, may hardware pang kasama. Hindi ko ma-configure.
Hindi naman siya kailangan ito figure. Gumagana siya pa.
So, tanging criteria ko sa terms sa paano masabing optimally placed yung PNU. Yung sa case ko na lang, assumption ko, yung PNU meron siyang kaya magsukat in 3 phases eh. So, hindi mo lalagay sa single-phase bus or two-phase bus kasi sayang information available eh. So, hindi mo maglalagay doon. Tapos from that, magba-branch out na yung rules. Tapos, halimbawa yung yung isang work kanina, sir, yung kay Aziz, wala siyang assumption, yung mga unang works niya before, wala siyang discernment whether single-phase or two-phase, yung single or two-phase or three-phase yung bus. Basta may bus dyan, potential candidate yan. Tapos, depende na lang doon sa methodology niya kung magiging candidate yun. Tapos, kasama rin concern sa optimal placement is goal ba natin ma-meet talaga yung optimal or given a certain amount ng PMU na mayroon tayo, ito lang yung kaya natin lagyan. So, balance out natin yung dapat, sir, or mag-play yun yung kung ano gusto natin achieve sa placement. Everything else will follow.
Questions? Meron po. Questions?
I want. Yeah. Please lighting. Validation.
Bali, anong niyo po kung paano ko na-discern na yun yung characteristics ng impedance fault? Okay. So, ang description kasi sa... Ay, sorry.
Galit, grabe.
Hindi. Hindi lang kasi nakita masyado. Pero yun, parang kapag high impedance fault daw kasi, meron siya actually baseline characteristics such that hindi, nag-increase siya muna. So, yun yung kita dun sa first graph. So, from this value, tumataas siya ng konti. So, that's different from a non-linear load. Tapos, iba yung itsura niya sa positive cycle dun sa negative cycle. So, meron siya asymmetry. So, yun yung in literature, and actually sa measurements din, from kapag nagsadya silang maglagay ng high impedance fault, yun yung makikita nilang characteristics na high impedance fault. And that's what we're trying to determine, kaya tayo gumagawa ng models for that. So, tinatry natin i-capture yung ganong characteristics na alam natin ang high impedance fault. Tapos kailangan i-translate natin siya into circuit components. Ayun. Okay po? Okay.
Were deep learning models considered for feature engineering?
Well, maybe. Repeat the question.
Sorry, deep learning models for
Feature
feature
extraction. Yeah, engineering.
Consider ba na? Parang hindi. Kasi matagal kasi yung sa deep learning, di ba? Kapag kunwari, okay, sorry. So, ang tanong niya, kung consider daw ba na for feature engineering, gumawa na rin ako ng deep learning model. So, kumbaga, hanapin ko pa lang yung parang relevant na criteria, gagawa ko ng model for that. So, for deep learning, hindi ko ito maano kasi kailangan tonto na work. Pero, for me, parang mahirap mag-deep learning for that. Kasi una, matagal mag-deep learning, di ba? Yun yung actually parang call ng deep learning. Pero useful sana siya kasi sobrang laki ng data set mo. So yun, parang kung okay lang sa application mo na medyo matagal yung processing time, why not? Okay lang, para ma-gather mo yung features. Pero dahil mag-gather ka lang ng features, hinahanap mo pa lang yung relevant na. Pero yun. Pero applicable siya kasi nga sobrang dami na data points na ginagamit. So yun, aware naman kayo lahat sa deep learning.
Neural networks. Neural networks.
Okay. So yun. Meron pa po. Ay, okay lang. Pwede namang magtanong na lang ng session. Thank you!
Sorry, ako na rin yung nakatanong kanina. Anyway, thank you, lady, for that very insightful talk on using state estimation to do analytics like through fault detection. In our next talk, we'll be doing another type of diagnostic where the objective is now to detect non-technical losses. I'd like to introduce you to our next speaker who will talk about this topic on non-technical losses, Ethel Luya.
My God.
Non-technical.
Non-technical.
Not technical difficulties.
Non-technical.
Bagal na. Wait lang. Yan. Okay.
Okay, so good afternoon everyone. My topic would be on non-technical losses. So first, definition tayo. Anyways, yeah. Okay, definition mo tayo, non-technical loss. This is any consumed energy or service which is not billed because of a measurement equipment failure or an ill-intentioned and fraudulent manipulation of the said equipment. Basically, ito yung part na sabi natin consumed energy of service, meaning sa buong, meron tayong consumed energy yung buong network. Then meron tayong mga metro. So basically, kapag sinamap mo yung meters mo, and then kung ano yung supposedly na sinupply sa'yo, yung difference na yun would be your system loss. And part of that system loss is what we call the non-technical loss. Ang category for it to be a non-technical loss is either intention, okay, meaning fraudulent manipulation, or meron kang equipment failure. So again, that difference that I mentioned is what we call the system loss. Now, may dalawa siyang category. We have the technical loss and non-technical losses. When we say technical losses, these are inherent in the system, okay? So they are your line losses, core losses, hindi nawawala sa ating system. Now, non-technical losses, these are due to human intervention or equipment failure. So ito yung mga nakaw kuryente, mga nagdo-jumper, line tapping. Kapag meron ka nasirang equipment, meaning yung metro sa bahay nasira for some reason, may it be sila or hindi, that's also part of a non-technical loss. Now, this system loss are all charged to customers, okay? So, ano nangyayari ngayon? This translates to millions of pesos paid by the customers. So, we want to reduce that kasi hindi naman siya talaga yung binabayaran mo, basically, hindi ko yung gumagamit. So the objective now is to reduce your system losses. And since technical losses are inherent in the system, unless you upgrade everything sa system mo, mas mahirap i-reduce ang technical losses. So what we're gonna focus on is reduction of your non-technical losses. So what are the common approaches for reducing your non-technical losses? Okay? So first, ano ba yung different types again of approaches in having your non-technical losses. So in this image, basically, we have yung, so first part, in this image, we have your distribution transformer, you have your house, you have your customer, and your meter. You have the database or your utility, yung information system na nakikipag-communicate if ever you have a smart meter. And then you have your utility employee na pwedeng kunwari nag-rove around your neighborhood to get your readings. So if this is your system, saan nangyayari yung mga non-technical loss? So one, you can have it line tapping sa diretsyo in between from your transformer bago dumating ng bahay, meaning you're bypassing your meter. Second, you can have meter tampering na nangyayari. Be it an analog or a smart meter, pwede mangyari both yan. Another one is yung cyber attack. Basically, yung communication between your database and your, let's say that's a smart meter, anything na tamper ka ng data, that is cyber attack. Non-payment of bills is also considered non-technical loss. And then, bribing of meter readers para sabihin na, sige, i-reduce mo na lang kung yung metro ko. That's also part of your non-technical losses. Errors in technical loss computation, meaning, ang estimate kunwari ng mga utilities, ito yung certain amount of system loss, pero since hindi niya na-capture doon, anything na hindi mo alam, that's considered as a non-technical loss. Again, we also have faulty meters and equipment and error and delay in meter reading. So what are the common approaches in non-technical NTL reduction? So again, kapag pinansin nyo, meron na tayong mga meters na cluster or mataas yung poles, nakakabit sa mga matataas na poles. Ibig sabihin nito, trying to make sure that your meters are harder to tamper with, mahirap siya kabitan, so lahat mabasa na siya dapat ng metro, okay? Siyempre, kapag meron kang mga defective meters, you want to replace that with newer working meters. There's also a push to roll out smart meters because they have They can store mga meter readings. They can be accessed supposedly remotely. Okay? And of course, yung mga pag-detect ng power theft is kapag nakita na nila, basically pag monthly may mga nag-iikot na mga meter readers, they also try to look at illegal branching, meaning ito yung mga nag-jumper. Kapag nakakuha sila ng mga reports from your linemen or meter readers or may mga customers na nagsasabi, so these are taken out. Your utilities take actions whenever you have this reports. Okay? And also, they also try to monitor that with a sudden abrupt or decrease in monthly consumption. So, kunwari for this month, you're paying, let's say, 5,000 or 3,000 pesos for your electricity. And then the next month, bigla na lang nag-reduce, let's say, ng 1,000. So, that can be somehow flagged or initial flagging as baka may something weird sa mga customers at bakit yan nagkakaroon ng ganitong reductions. So, nagkakaroon ng observation time and then basically this process and then finding out if there is some anomaly in that load, okay? So aside from that, the current different approaches now that's going on in researches, if you look at the papers, is that for data analytics approach, meaning aside from just looking at your meter readings na monthly, or relying on monthly reports from your linemen or customers, meron na rin tayo ngayon, especially if you have smart meters, you also look at yung, you're looking at the time series again of the load consumption. If you have, you can also use your voltage or current measurement readers. Customer information, meaning, what if alam naman ng utility na this neighborhood is supposedly mga mas mayaman, so dapat in a way mas mahal yung kuryente, so that's nothing anomalous. But if this neighborhood is something na somewhere na alam mo hindi ganun ka mga low-income class, and then may spikes ka ng consumption there, so that's part of your customer information or knowledge na pwedeng gamitin in your analytics. Again, if you also have a good network topology, and then we have, again, before if you have an inspection of data and you have an idea of your demand and load factor for your system. Now, if you have all this data, there are a lot of techniques that you can use. Okay, so again, you can use a load profiling. For time series analysis, you can also do state estimation, linear programming, and various machine learning algorithms for detecting this non-technical losses or energy theft. So I'm going to discuss next now is, so what I'm going to discuss next are the research topics done by some of the graduates here in EEE. So actually right now I'm focusing on trying to look at correlations between different meter readings. So the assumption here is that what if we have the power readings, if you have a smart meters and you have a power measurements and voltage readings of those meters. Of course, we know that there will always, now here, what I'm trying to look at is correlation between these readings. What if at this, let's say, time period, this red box, nagkaroon ka ng sudden reduction? Basically, let's say, nagkaroon ng bypassing ng meters for their customer consumption for load 3. That's the yellow line. And then, of course, magmamanifest din changes niya sa yung voltage reading. But if, let's say, you had a meter bypass, your voltage reading would still be normal, but then yung power measurements na nabasa would be, let's say, reduced by kung ilan man yung dinivert mo, okay? So what we see here on this graph is basically your correlation coefficients. And what this says is that, let's say, if you, in this stream, kapag wala kang nangyaring anything na sudden reduction or bypassing of your meter, ito yung range ng iyong basically correlation for your voltage and your power readings. But if suddenly nagkaroon ka ng reduction, meron tayong initial result dito na nagkaroon ka ng spike, so that this red one here represents for your meter 3 or your load 3 na biglang nagkaroon ng weird relation between your meter, between your voltage and power readings. So these are just initial results from this methodology. Another study being done by one of our grad students is that basically ang ginagawa with these linear equations is that alam natin if we have a check meter, basically measurement here is supposed to equate or equal to the sum of your different meters. Okay? So given in this equation, basically what it says is that for any time step, meaning time step 6, 7, 8, 9, 10, for any time step, let's say time 6, your summation of for your check meter is supposed to be equal to your different meters, okay? Now, as your time moves along, let's say that's we move 6, 7, 8, 9, 10, you also have these coefficients for per meter load, okay? So, ang ginagawa dito, if, let's say, you have this load profile for meter 3, and then bigla ka ng sudden reduction, if you now look at yung coefficients, or if you try to solve that linear equations, your coefficients is supposed to be equal to 1 if nothing is wrong. Okay? If it's not 1, basically, yun yung sinasabing may weird sa system mo. Okay? So, hindi ito yung pinaka-updated na size. Pero supposedly, ang example na mangyari dito is that with meter 3 as your fraudulent customer, supposedly everything is 1 aside kahit this is supposed to be at somewhere 3 or 4. So lahat sila 1, 1, then your coefficient would be greater than 1. And then the rest would be still at 1. So that is one of the results na sinasabi. Okay, looking at these linear equations, if we have coefficients greater than 1, then that will be flagged as an anomalous customer. Now, this is another methodology done by one of the grad students. Ang focus naman nito is voltage measurement readings. So again, dito ang kinukuha natin is energy summations. Here, what we look at is voltage estimates. So what this just says is that the voltage in your individual meters, this dot that represents that, is supposed to be equal to your check meter, meaning yung distribution transformer mo na meter, plus this is for your current measurements ng kuha mo per houses. So kaya siya state-based or state estimates is that dito you're trying to compare now kung ano yung with this equation, yan yung maging state estimates mo for each of your household meters na voltage readings. And then at the same time, you have your actual voltage meter readings. So what happens is, kino-compare mo ngayon yung estimate mo with your actual voltage readings. And that difference, if there is a difference, then that would be also flagged as your anomalous meter load. Okay? So in summary, basically, at least for non-technical losses, there are ongoing researches on energy theft using different types of data. So the assumptions for this could be using voltage and current readings or power or energy measurements. And then again, these measurements also uses different methodologies. Some of us use for the time series, cross-correlation, linear regression, and state estimations. And since this is still an ongoing project, part of the future works again is still to model other types of theft simulation data, expanding to a more complex network, improving this algorithm for energy theft detection, and of course, validation of results. That's all. Thank you. Any questions? Questions? Wala? Okay. Thank you all for listening.
Thank you, Ethel, for that interesting talk on non-technical loads. So for the next part of our seminar, we'll take us back from state estimation and detection problems, and take a look at possible ways to implement other ways to make the distribution grid more resilient. So for our next talk, I'd like to call on JB Bonifacio for his talk on distributed energy resources in resilient grids. Nakalimutan ko yung name ng talk mo.
So hello, good afternoon. Yes, I'm Jimmy Fascio, and today I'll be talking about distributed energy resources as applied to resilient grids. So specifically, I'd like to discuss my approach for this for distributed energy resources as they're applied to resilient grids. Because right now, I'm seeing from my review of the research that there are different there are like separate approaches to DER. And I'd like to sort of unify them in an interesting framework, and I'd like to discuss that today. So, I think the first question that we ask is, what is DER in the first place? As we may know, DER stands for Distributed Energy Resources, which refers to the modular energy generation units connected to our power grid. A typical example of this are generator sets that we typically see maybe in sa mga malls or sa mga bahay natin. And, but really, you know, the more interesting example that you'd want to actually see are renewable energy resources. That's a big thing right now and something that we're always pushing forward. And in addition to this, we'd also like to look at applications of energy storage systems, or ESS. So, as an extension of this, there's actually an ongoing emergence of something called the microgrid. As per its definition, a microgrid is a power distribution system integrating DGs, ESS, and other controllable loads. I'd like to actually simplify this because, as we've seen from the previous slide, essentially a microgrid is a power distribution system with properly integrated DER. So, much simpler explanation and something that I'd like to sort of go back to as we go on the discussion. So I'll be talking about approaches to DER for resilient grid studies. And from the course of my study of the literature, I've sort of grouped them to two possible approaches. First one is a bottom-up approach where you treat DER as sort of resource or a disturbance for the network. This takes advantage of the characteristics of DER and finding out kung ano yung parang based on sa characteristics, paano mo i-model yung network properly or how do you control the network properly. We'll discuss it later. And another one is the top-down approach, which, as I'd like to call, maybe a collective treatment of DER in network with general assumptions on the DER's performance. Actually, if you look at it, para siyang yung microgrid lang in another way of, the definition of a microgrid is discussed in another way. So these are two approaches that we're looking at. And for this talk, especially since you focus to is from a bottom-up approach, dun muna ako magpo-focus. Pero we have research, for example, sila Fred Barasarias, who's doing a lot of work in microgrids. I don't have time to discuss his own work here, pero the top-down approach is something that he tackles. So, pan-versus siya. So, what do I mean when we say bottom-up, right? DER from bottom-up, resource or disturbance. So, as we know, when we talk about renewable energy, which is an example of DER, it's a variable sort of resource with uncertain levels of energy production and depende rin sa location kung ano yung amount of energy mo makukuha mo. When talking about wind or solar, parang ganun yung characteristic ng renewable energy. So the question you can ask coming out of this characteristics is, so first of all, ano ba yung characteristics ng specific DER na you're looking at? It could be your nat gas, your diesel generators, and it could also be your renewable energy. Now with in mind, how would this affect the way we design planning or control strategies for our network? So this is the approach I'm looking at. Ito yung in reference to our whole study of resilience. Instead of starting from a state estimation standpoint, you look at first as ano yung capability ng grid natin and how do we design control strategies coming out from that. And then that's how when you start discussing resilience of the grid. So yun yung approach ng research ko specifically. So just to emphasize it further, when we integrate DER, there are actually good and bad perspectives of it. When you have more integration, it implies maybe number one, it's a problem because DER, as we mentioned, introduces grid instability or variability, however you want. But it can also be a source of benefit because there are many things you can do when you have distributed points of energy in your grid. I'll give some examples of it later, pero these are the two aspects that you would have to consider when you're doing research with DER. So I think naturally, okay, so you have these two phases of DER. How would utilities approach this dual nature, right? So conventionally, your approach is to actually treat them as separate problems. So na lang na, when you do this one research, DER is a problem. Or maybe you do one research, DER, we assume we can control all of these distributed points of energy, and it's fine with that. So as we see, DER's disturbance, it's just an example of the previous approaches that research have done. For example, studies here have taken a look at trying to measure the variability of renewable energy for comparison of different RE resource capability. So that's one of the research that you can look at when you're trying to think about DER as a disturbance. With regards to DER as a resource, there's a huge extensive literature on using it as a resource. For example, optimizing RE resources with the goal of achieving greater network performance. So when we're talking about this sort of research, we're talking about distributed or centralized control of your distribution network. So you take advantage of the fact that marami kang distributed energy resources in your grid. So I think a question comes up is, what about the middle ground? Or we treated these problems separately. Is it possible to combine them into a single, or try to the point where it's we consider both aspects of DER. So realistically speaking, kasi, grids are typically made of DER that you can control or you cannot control. Factors like, for example, sa industry natin ngayon, we're talking about integration of renewable energy. May mga policies that introduce DER as in mass. Like, for example, the FIT program where you try to integrate as much solar into your grid or renewable energy into your grid as much as possible without consideration for grid control. But realistically, you'd see your grid as having sort of a mix of that, where you have large, huge numbers of renewable energy that you can control, and then you also have on the one side some renewable energy that you can control. So I think this is a way to jump into our whole topic on improved sensor systems like the micro-PMU. I think you can try to answer this problem by figuring out how to integrate the micro-PMU in order for us to help solve the problem. So that's one of the approaches I'm taking a look at right now. And I guess you can start by, let's make use of the available data to try to answer this problem. For example, let's take a look at in phasor angle that we've been discussing since the start of this seminar. One of the things I'm looking at right now and done research on is something called the angle difference metric. I think it's been discussed in yung mga research nila Lady and Anton. But for this case, I'm taking a look at it from the perspective of yung renewable energy resources natin in the grid. We have this grid, a simple grid with 4 buses, and meron pang renewable energy resources. Specifically yung WF1 na yan, yung assigned resource na hindi natin ma-control. Yung WF2, yun yung assigned resource na kaya natin ma-control. So what this does, this angle difference metric is, we're trying to figure out, we're trying to model the network such that you have this controllable and uncontrollable resource, and trying to figure out ano yung angle difference in that sort of system. So the research I've done with this is mostly on trying to model the network with DER as a function of voltage angle difference. So before you start looking at this whole controllability paradigm, I think yung first question is, can you even model the network in the first place using yung phase or angle difference? So this is one of the research I've done recently. Let's take, for example, itong grid natin. You have theta Cs of A, which is essentially the angle difference between the bus T and bus GSP, as you can see in the figure. And then you just model it using, let's say, a linear model of theta Cs of A with respect to your RE capacity, your load demand, and line impedance. So this is a simple network modeling exercise that you can do. And from our research, we are actually able to figure out yung mga coefficients of each of these variables that we're talking about and model the network nga using angle difference. So that's possible. And then from this point forward, you can actually take advantage, knowing this model, you can take advantage of this angle difference that we're talking about in order to do other aspects of resilient grid studies. So moving forward, actually, one of the ongoing work that we're doing is actually trying to have a better representation of our network, taking into account yung mga sinasabi ko kanina, controllability of DER. So one of the things we're looking at is this concept of firm and non-firm DER. We're talking about a firm power plant is essentially a huge megawatt range power plant that you cannot control, and then you have a non-firm power plant, which are smaller kilowatt level power plant that you can control. And then these studies have started to take a look at how to integrate these two into a single network. So this leads actually to more interesting studies that I haven't actually, done, but this is interesting, like maybe future work that can be done with this sort of with these sorts of ideas. So what if we can apply this sort of phaser-based approach to network optimization? So you can take into account, maybe you have an angle difference-based network metric that you use to model the network, and then you use the same angle difference or maybe angle-based constraints in order to run your optimal power flow. So these are just some of the possible prospects of this sort of approach to DER. And this is something that can be done and still, has to be researched by in order to see if it's feasible and checking. So in line with that, actually, as a summary, we talked about DER in resilient grids from sort of a bottom approach, where we treat DER as both a resource and disturbance. And of course, we try to consider yung improved sensor networks natin, yung PME natin, in order to integrate DER better and to make use of these distributed energy resources. So ongoing and future work for this, I would say, new field of research is maybe try to represent networks more realistically, take into account yung way na integrate DER based on what we see sa industry. And then, you model the network based on this information, maybe use phaser angles for that. And then also, maybe as a next step, optimize the network with this knowledge. And with that, I think it's all for now. Thank you. Questions? Anyone? Yeah, it's based on presentation. Well, I think yung point naman is a general, what you'd say, look at DER as applied to grids. So, in general question, also. Okay. Okay. Thank you.
Okay. Thank you, JP, for that insightful talk on implementation strategies on on DERs. So next, we will try to pivot again to the left, and we will try to redefine, to look at resilience from another perspective. So this time, we're going to look at it from a more economic standpoint, where we consider electricity markets and interruptible loads. So let me invite the next speaker who will talk about interruptible loads, Christian Yang. I-impromptu ko lahat. Yung MC ko.
Okay, so yeah, basically I'm the last talk, and given 20 minutes to talk about interruptible loads. So send me. Okay. Okay. So yun nga, sabi nga ni Ian, and of course, continuing with the concept of resiliency. Of course, we have to talk about the normal operation of a power system. Sabi nga natin, the normal operation of a power system is when we don't notice that it's operating. We just know at the back of our minds, meron tayong kuryente, meron tayong nagagamit na para sa mga computers natin. We can do stuff basically with electricity. But on hindsight, we don't actively think about it. We just know that it's there. And that's part of operation of power system. And yun nga, yung concept of resiliency, if we're going to revisit it, and in the previous talks as well, if something goes wrong, diba, we definitely notice it. If there are faults, mawala ka kuryente, aga sa utility, wala, nasa na kuryente ka? Galit ka, mag-aaway yung mga companies and whatever, no? But that's the operation of a power system. And the goal of resiliency is that basically, kung nangyari itong mga masama na mga bagay na to, that interrupt or basically daily lifestyle, then we must be able to, or the power system must be able to recover. Okay? So the power system at all times must maintain frequency and voltage stability. So this is basically yung mga non-obvious stuff, like for example, yung mga generators mo sa power plants, they should all be basically following some setting or whatnot, no? And we have regulations for that as well. No? So, alongside these normal operations, our system operator set up a very flexible power system to address our uncertainties in demand. No? So, parang hinuhulaan ba ng system operator kung kailan buksan yung electric fan mo? So, syempre, may maliit na effect yun. And of course, you basically turn on or connect a industrial power plant, then that's gonna draw some load as well, no? So inaalam ba ni system operator lahat ng ganung bagay? Of course not, no? But they have estimates, and what we do basically from a very supply and demand perspective is we have a reserve margin. So in the graph shown, no, we have, for example, a load profile of demand. So yun is shown in the graph. And then what system operators do is they set up basically reserve margins, no? So may available capacity natin at almost any point in time should be greater than the demand. And this is the normal thing, no? However, the question lies is, what if something goes wrong? Kung nagkaroon ka ng fault sa isang substation, and if you do your load flow analysis, if the substation is out of commission, of course, mayroon kang mawawalang mga load, right? And if you look at it from a transmission perspective, for example, nawalan ng isang transmission substation, then you also probably lose some power plants as well. Kasi if you check out maybe the topology, baka na-disconnect na-isolate na yung power plant location. So what happens is, if you look at the diagram, then bababa yung reserve layer. So of course, pag yung reserve layer mo, palit yan, lumalapit yan sa demand. That's dangerous. Of course, you don't have, basically, if you lose anymore, then the system will collapse, and that's a very big issue. Okay? So, yun nga, how do we provide resiliency from a different perspective? So, traditional solutions, dito sa pag-solve ng mga problema, is to involve tapping of generation. So kung nga rin, nagkaroon ka ng fault, then you might try to bypass some isolated sectors, tapos kumuha ka ng mga plants from the portion na meron pang connection, right? And also transmission capacity. So marami talagang bagay dito that involves resiliency. But ngayon, palitan natin yung perspective. Kasi palagi nating approach is increase capacity, gumaning protection systems. But sometimes, in most cases, mabagal yon.
of course, if you do fault analysis, meron ka pang detection time, hanap mo pa. If you do dispatch, and if you commission power plants to increase their capacity or magdagdagan ng planta, then may lag time yun. I-ramp up pa nila yung power plant nila. So that basically the response may be very slow in cases na kailangan mabilis kang mag-respond. So they invented or somebody thought of the concept of doing demand response. Imbis na supply ang response is demand. Because demand is patay, di ba? Patay mo yung load. That's faster usually. So this was introduced in the introduction. Now there are different methods for demand response. So meron tayong peak clipping. So what that basically is, you have, for example, at noon time, mataas yung konsumo ng kuryente. Gawin mo, pagin mo yung mga loads mo, tanggalin yung kuryente nyo, bayaran ka namin. Then, mababayaran. No, and the idea is, of course, basically, the mere act of doing that will help the system cope in some way. No? Pwede mo rin sabihin sa kanila, for example, napansin ko, gumagamit ka ng kuryente 12 o'clock, ay 12 noon ng plancha. Gamitin mo sa 4 p.m. ng hapon. Diba? Is load shifting. So, basically, yung demand response concept is trying to address yung mga problems natin, well, yung our traditional problems with a different perspective. What if we modify the demand? Okay? So now, let's go to the concept of interruptible loads. And these two things are, well, they're tied anyway. But what are interruptibles? They are the customers, basically, who are compensated for modifying their load requirements. So, basically, sila yung mga kinakausap ng mga utility na magbawas kayo ng kuryente in this mechanism. So, we have different mechanisms as was shown in the previous slide. So, etong graphs na to, yung mga yan, these are the mechanisms. Okay? So, kausapin nila yung customer, and then, of course, it's a control problem as well. How do you do it and all that stuff. But the goal is to modify the load, to do something useful. No? And in these interruptible loads, they are motivated by different things. Pwedeng bayaran mo ako, pwedeng mag-apply ka sa akin ng different electricity rate, pwedeng pag ginawa ko to, one trip vacation to diba? So, parang ganun yun, no? But basically, interruptible loads are, you give them something and they interrupt the load. Essentially, yun na naman ibig sabihin, no? And of course, it might sound, okay, very easy, madaling kausapin. Where does the math go? Where does the science go? Saan na yung mga algorithms na... I'm trying to avoid going into that, but yun nga, let's just talk about yung implementation requirements of ILP. So, in the Philippines, we have ILP. Meron tayong Philippine Interruptible Load Program. I'm not going to discuss that. However, I'm going to discuss the overall aspect of implementing ILP. Ano nga ba? What does it take for the distribution utility to implement ILP? Of course, it's not only the distribution utility does try to manage this, but also does the system operator as well. No, but it's just basically a conversation between a whole lot of people. Ang goal nila is to do reduction of the load. And it is in the hope that if you reduce your load, if there's an emergency, you save the system. No? A lot of problems in the system na hindi na resolve is basically hindi ka makakapagsunod sa supply and demand balance. No? Especially, which are of course consequences of, for example, if you have fault problems, etc. So, first thing that a distribution utility that has to decide is basically what interruption mechanism will it do. And this question matters kasi iba-iba yan. No? If, for example, you do an energy conservation demand response program, then you would request your customers to basically buy more efficient appliances. And that would be their solution to that, right? For example, you would choose a load shifting problem, then you're not really interrupting load. Basically, yung load mo, lumilipat lang ng oras. No? That's additional consideration. Kung load mo lumipat ng oras, yung nilipatan ba niyang oras, hindi siya kailangan. Kumbaga, parang, there are a lot of considerations there as well. If you do, there is also yung ating interruptible loads. I didn't mention this, but they can also run their own supply. So kung meron sila, this would be yung ating mga malalaking planta or ating mga mega mall or yung mga M's natin, no? They would have their own backup generators. And if there's a problem in the system, pwedeng request ni Meralco, for example, that i-run nyo yung backup generators nyo. Yun lang muna. And then we'll just pay you for run your backup generators as compensation for basically yung paggamit ng backup generators, no? So, what methods of interruption do we employ is a very, very important consideration because these different mechanisms spell out different areas of research. So, meron area of research na just purely interruption, meron siya mga control mechanisms, meron siya incentive computations, and all that stuff. And it's also different for load shifting. Iba-iba yung ano nila. But from a softer, more general perspective, they're all about modifying the demand. Okay? So, the next question that we would like to ask when we implement our interruptible program is, sino yung mga customers na kausapin natin? Who are the interruptible loads? Diba? So, pwedeng, of course, yung mga interruptible loads, pwedeng magaling sa residential, pwedeng commercial, pwedeng industrial. No? And mind them that yung kanilang mga consumption patterns are different. So, maraming pumapasok na analytics sa... So, yung residential, usually, it would have a very high consumption dun sa, of course, yung pag nagbe-breakfast sila, and then, di ba? Of course, at night, baba, right? So, of course, if you have commercials, then mataas siya the day, and then pagdating sa gabi, mababa. So remember, in the demand response concept, ang unit mo is yung load. So now, you have different customers that have different consumption patterns, different load patterns, and that constitutes a very difficult control problem. Diba? Kung ang kailangan mo lang reduction, let's go back to this diagram. Kung kailangan ko reduction is just around 12 noon, kasi dyan bumagsak yung reserve layer, then saan ako magtatap? According to all of my customers, hindi man sila gumagamit ng load sa 12 noon. Diba? So it's a control problem in its entirety. And of course, involving that decision of deciding what customers are there is involving yung pag-estimate ng konsumo nila. No? So we are going to forecast yung tinatawag nating baseline load profile. And the baseline load profile is essentially basically meron silang normal consumption pattern, no? And if we collect it, makukuha natin yung regular consumption pattern nila. But we will not see yung consumption pattern na yan when we ask them to interrupt. Right? Kasi pag interrupt natin sila, di makikita natin is yung load profile na interrupted. So you don't know what we call as the counterfactual. What load would have been there?
Baseline.
So now the question is, paano may co-compute yung incentive? Based on, so ngayon, diba? So you have to forecast it as well. Marami talagang considerations there. We call that the baseline. Okay? And further questions arise is, kunwari, tumawag ka ng customer, sinabi mo na mag-interrupt sila. How do you actually track na nag-interrupt nga sila? Sinunod pa nila yung kontrata nyo? Diba? And then, how do you compute the incentive? So, pwedeng fixed rate, pwedeng different across different customers. And it's really, it gets really hard quickly. But of course, it's just control. So, it's control theory. And yun nga, how do you assure participation? How do we compute the incentives? So, all of this lies on the development of what we call as the interruptible load contracts. So, yung ganung information, doon nakalagay sa interruptible contract. Yung mechanism, okay? And now, looking at it from a very large perspective or macro perspective, yung last three natin is mostly micro, no? It is the discussion between the utility and a single customer. Pwede siyang ganon, no? But how do we basically, for example, perform a dispatch? So let's say I have 100 customers. They all have different loads. They all have different consumption patterns. Pero at this time, specific time frames, ito lang yung kailangan kong interruption. No? So, basically, parang, you can imagine, it's an optimization problem. Optimize ka, control theory, optimize dispatch, no? Para mahanap mo yung probably from conflicting objectives, yung pinakamurang way para ma-achieve mo yung interruption requirement. This is from the personal distribution utility without really, yung term natin is parang yung customers natin mababot kasi ini-interrupt mo sila. Of course, di ba? Pag i-interrupt mo yung customer mo, ang palitan, babayaran mo siya para tumingin siya sa black screen ng computer niya. Para siya makita kasi sarado yung computer niya. Di ba? But, of course, so, yun nga, how do we dispatch these messages? So, there are many mechanisms, pwedeng text mo sila, ganun, all the stuff, no? And yun nga, how do we optimally allocate interruptible loads across time scales and different interruption requirements? Okay? So, since this seminar is about, state observation and data analytics, saan pumapasok yung data analytics sa interruptible load graph? Okay? So, it's just basically, it improves yung ating data for our, so in my research work, I've done a lot of work sa load profiling, pero yung pinaka-goal ko was to basically estimate the baseline load profile. So I've gone through 3 major algorithms. I've gone through load forecasting, I've gone through load clustering. These are machine learning algorithms anyway. I've gone through energy disaggregation, all of these things, just to basically guess kung ano yung sumo ng isang bahay the next day. No? So based on what the yung mga consumer nila, and all these algorithms combined, you can guess and have a good guess of what their loads are. And you can use that information for scheduling and optimal dispatch. Okay? So it can also improve yung ating basically yung history. We can use the data collected to measure yung participation. Kung yung customer talaga ma-participate siya. It matters kasi, syempre. Diba? Kailangan mong ma-compute yung babayaran mo sa kanila. Sila nila sa'yo, ay, nagbawas kami. Pero if you don't have any real tracking mechanism, baka upload ka lang nila. No? So, you of course, with the data, with a lot of data it comes with, you can perform more research. No? So you can perform different case studies to improve all of these implementation requirements for the island. So in terms of research, I didn't prepare really very informational research. But nilist lang namin dito yung research na ginagawa namin. So yung first one, yung use of load profiling algorithms to perform baseline estimation and dispatch. That is yung aking work nung graduate studies masters. Basically use load forecasting, load clustering, and energy disaggregation to just guess what the next day consumption is. Okay. Yung number 2, this is for Miggy. For Miggy, you wanna talk about it for a while?
Okay. So I didn't expect actually to be called, but then, sige, I'll go back into actually discussing what I did for my master's research. So if you look at this, where did you put that?
Oh, wala.
Here. If you look at this slide, you can actually decompose our research between Christian and I into 2 parts. The top line would be the top bullet would actually correspond to my research, while the bottom slide would correspond to Christian's research. So my research focused on computing incentives for the demand response program, the interruptible load program. The big issue we face though when doing this research is that normally when dealing with participating customers or generators or customers, you normally don't know their cost functions. Because normally when you're curtailing energy, you wouldn't know what their cost to curtail is. So the big issue is we have this lack of information on what the marginal cost of curtailment is. So how do we actually do an optimal dispatch problem when you don't actually know these cost functions? One big assumption we made though for this is that we can actually find out what the possible cost functions of the utility function is. And then, so how do we ensure participation? We always make sure that the profit of a single generator for all possible cost functions will always be non-zero, which means these generators will always profit. Given this, how do we do a minimum cost for the distribution utility, a minimum cost optimal dispatch? So if I can assure that everyone has a positive profit, no matter what no matter what, then I will assure that the program is resilient or robust. Because now, everyone will participate and will say yes to the contract. So we computed the estimated using a minimum cost optimal dispatch problem, and we assure participation by making sure that they will always get positive profit no matter their cost functions. And this is some sort of robust optimization, robust control framework. So that's in 3 sentences, 5 sentences. That's my research.
Thank you, Mili, for the. Let's just finalize it. So, yun nga, the number 3, of course, level research extensions is improving yung optimal dispatch. Okay? So if you're familiar with economic dispatch, then it's essentially the same thing. So economic dispatch is parang binabalance mo yung generation and supply. Okay? Number 4, of course, developing an effective way to monitor interruptible load performance. So kung nagpa-participate talaga sila, kung gaano ka interruption, or if they're following the contracts, etc., etc. Okay? So in summary, yun nga, I've just discussed interruptible load program, or specifically interruptible loads, which are essentially just customers that you can interrupt. Yeah, siya, interruptible loads. But the price of their interruption is you have to pay them. Okay? And they become basically sellers. No? So look at it from a very market perspective. How do you balance yung supply and demand, yung bentahan, no? So it's a dispatch problem. It's an economic problem that is, of course, contextually applied to power systems. Okay? So that is my presentation on the interruptible loads. Any questions? Questions? Wala. Okay. Wala.
I can't really call it an insightful talk because I'll be talking about myself then. So thank you, Christian, though, for your talk. So that's it, actually, for all today. I hope you all had, all got good ideas of what we were doing for our research. And so for the next part of the talk, I'd like to call Dr. Alan Neves for the concluding remarks of this seminar. Yeah. Just realized robust control pala ginagawa ko sa thesis ko. Yan mo na natin.
Okay, thank you, Miggy.
First time ko ba?
First of all, I'd like to thank everyone for coming this afternoon in such short notice. And I guess one of the objectives of the project, aside from doing the research, of course, was to disseminate the information, the knowledge that was generated in the conduct the research to as many people as much as possible. Of course, we target our students, graduate, undergrad, and also try as much as possible also to reach out to stakeholders in the power utility. So we will be scheduling, I guess, future talks like this that will reach out to those other stakeholders. But of course, for the institute, I guess, for a student, one of the main objectives here is also to generate interest in the research area that we're conducting research in. Okay, so as much, hopefully, those of you who have not decided on a research topic will have already some idea of what research to do. I would say that the research that we have been doing has been just exploratory. I mean, has always been exploratory, and I would say there's a lot of research topics that are still possible even within this limited range of research that we're doing. And again, I hope that those of you who have not decided on the topic will also join us doing extending this research. Okay, hopefully we can also get that future research which will extend the results that we get from this study. And again, I'd like to thank you for coming today. Always, as I said, if you have any questions, you can approach me or any of the faculty members, even the graduate students that have talked.
Former graduate students.
If you have some questions, clarifications, they help you to get a better idea of possible research topics. And probably also help you complete your requirements for your undergrad and graduate studies. I want to thank the organizers, students who have been diligent at working on this seminar and organizing the seminar, I guess. And more, I'd like to thank you for coming this afternoon. And with that,
so now we officially end.
So now we officially end this seminar. There's food outside if you guys. There's food outside for you guys, and there's a certificate of attendance you can collect outside also. Okay. Yeah. Thank you.
Ay, sorry nila milk tea natin.
Ganun siya mag-
Gusto ko na lumabas. Robust control pala yun. Hindi kasi it's robust to robust na anytime. Meron na ako next January. Pinuntak ako ni Roy. Pinuntak ako si Roy. Starting January, mag-collaborate kami. Sunday. Next quiz. What if I learn optimize brain?
So you're gonna do research while working?
Yeah, publish another paper. Pero ang paper ko this time will be focused on robust control. Na given ito yung estimate ng type, ano pa rin yung worst case? Exploitation. Talking about application. Tsaka ko ba, ano ko na-realize? Yung video na pinapanood ko kanina. Diba? Ito kalito, nag-computer vision ako.
Nga pala, doon sa nagpo-post ka na ano?
Face detection, face recognition. Ngayon malayo. Detection, ano ba? Detection.
Ito panggal na lang.
Pero iba lang yung dinidetect mo. Hindi lang false. Ano lang ako, mukha. Mukha lang. Pero okay lang. Machine learning, kaya natatanong yung mga deep learning stuff. Hindi mo na-realize na, hey, hindi mo kailangan i-change yung
Problema sa deep learning lately, kailangan yung model pero yung behavior niya, per bus, per type.
No, for speech engineering, deep learning for speech engineering.
Alam ko pa sa Ikaw, ang ginagawa mo dyan? Ang source of power. All these EE talks, walang source of power. Good job. Alam mo ba yung ano, ilang percent yung inano pa siya? Oh. 1%. Flexibility. Hindi yung background. Kung wala ka pagkain doon, Jara. Okay na.
Thanks.